Okay, so we're going over the answers for lesson 37-2. It said go back to item 8A and write the factor you used to determine the ratio of the surface area with an exponent. So we found the ratio was 3 to 4. And so for area, 3 to 4 squared, and for volume, it was 3 to 4 cubed. Okay, true or false? If the radius of a right cylinder is increased by a factor of 3 and the height stays the same, the volume of the cylinder will increase by a factor of 3. Explain your reasoning. Be very careful on these type of problems. I may not have stressed enough on this table that we filled out right here on this. This is only true if all your measurements, each measurement on your figure, whatever you have, your entire figure, if one part changes but the other part doesn't change, this relationship does not hold true. So on this problem over here, it says we're dealing with a cylinder and only one thing changed on the cylinder, the radius, but the height did not change. So our it wants to know if the radius, what would, so they're asking about volume. This will not be a over b cubed. It will not be that. And the reason it will not be that is because all parts of the cylinder would have had to have changed. The radius would have had to have changed, and the height would have had to have changed by a factor of 3. Then it would have been this one, right? It would have been that we would have cubed it, but it didn't. So what you have to do in a situation like this is write the formula down for volume. Volume is equal to, for a cylinder, volume is equal to the area of the base, which is pi r squared, times the height of the cylinder. So that's the normal one. That's what we have. Now we're going to take that, and what's changing? It says our radius. And how is our radius changing? It's 3 times what it was. So now instead of our radius just being r, now it's 3r. So we're still going to square that, and then we're still going to multiply it times the same height that we had. So now, how is this answer right here different from this one? Well, if you pay close attention, you'll see that it is 3 squared times r squared times h. So if you pull this out in front, then this is exactly what we had before, pi r squared h, pi r squared h. So this is the same, and this is how much bigger it is. So it says the height will be the same, the volume of the cylinder will increase by a factor of 3. And the answer is no, it's going to increase by a factor of 3 squared. And a lot of people will put 3 cubed because they think that this falls under that same situation as when all dimensions changed. If all dimensions had changed, it would have been 3 cubed. Okay, so number 12. They want to know if the small coffee can is 3 inches tall with a radius of 2. So it's 3 inches tall and it has a radius of 2. Okay. And it sells for $6.26. And the larger can of coffee is 9 inches tall with a radius of 6. Okay, so we've got 3 inches tall and 9 inches tall. That's multiplied by 3. And then we've got 2 inches radius, 6 inches radius. That's also multiplied by 3. So both measurements, or all the measurements, changed by 3. So it's a scale factor of 3 to 1. Okay, so now it says, is the larger can of coffee priced proportionally? So if it's priced proportionally, now then it should have the same ratio. And so 626 compared to 1252, that is not times 3. That looks like it's times 2. So it is not proportional. No, the volume of the larger can is 3 cube greater, but the price is doubled. Yeah, so well, proportionally with the volume. So yes, if this is the scale factor 3 to 1, then we would cube that and it would be 27 to 1. That's how the volume would change, but the price is only times 2. Okay, so number 13, the radius and the height of the cylinder are reduced by 75%. So that means our scale factor is 0.25. 75% is how much is leaving, 0.25 is how much is staying. So it's 0.25 or 1 to 4, however you want to look at it. Describe the effect on the surface area. So if the dimensions, the radius and the height are changing by 1/4, the surface area is going to change by 1/16 because we take this and square it. So the surface area is reduced by a factor of 16. So 1 to 16 is the scale factor. And then it says if surface areas of 2 similar cylinders are 10 pi feet squared and 160 feet squared, what is the ratio of the volumes? You have to use 10 pi and 160, but remember that's not a to b, that's a squared to b squared. So reduce this down, that's 1 over 16. Now take the square root of it, because this is, notice it's feet squared. Then it's down to 1/4. So 1/4 is the scale factor, and then you take that and cube it to get the scale factor for the volumes. So that is 1 over 64. 1 to 64. So we made the ratio out of the areas, reduced it, and then took the square root of it. If you could take the square root of it before, then you can do that. Doesn't matter what order you do that in. But I know the square root of 10 is not a perfect square, so that's why I wanted to reduce it. Then it turned into 1/16. Take the square root of that to find what a over b is. And then once you have a over b, you cube it to get a cubed over b cubed. Describe the effect on the volume of a square pyramid if its height is doubled. Again, did every measurement change? No. So be careful and don't say 2 cubed. A lot of people are going to say, oh, it's 2 cubed. No, it's not. It's not 2 cubed because every measurement didn't change. So over here, I drew a picture, and again, I wrote the volume down very much like I did the cylinder up top. What's going to change? Describe the effect on the volume. So I use the volume formula. If its height is doubled. So this is the volume formula right now. And I'm going to double the height. These measurements right here, it's a square pyramid, so these numbers are the same. Those numbers are not going to change. I'm just going to double the height. Okay? That's supposed to be a 3. So now, instead of having 1/3 x squared h, I have 2 times 1/3 x squared h. So this is the same as this. All I did was factor that 2 out. That's just a long multiplication. 1/3 times x squared times 2 times h. So I just factored the 2 out in front. This now is back to exactly what it was. So what happened to the volume? It doubled. The volume doubled. All right, that's the end of lesson 37. So I believe you have an activity practice now. Check your homework sheet for what problems you're supposed to do.